4.5 billion years ago, Earth formed out of the solar dust cloud. 200 million years later, the first continents and oceans were developing. Meteorites brought water and amino acids, the building blocks of life, to the surface of the planet. The investigation now moves forward to the period 3.5 billion years ago. New forms of life were about to emerge, which by their very existence would create new kinds of rocks. But life as we know it needs oxygen, and 3.5 billion years ago there was no oxygen on Earth. At the time, the atmosphere was deadly poisonous. Volcanic eruptions filled the air with a choking mixture of sulfur, methane, carbon dioxide, and sulfuric acid. But primitive life forms did exist. The fossilized remains of strange coral-like structures have been found in rocks more than 3 billion years old in many parts of the world. They are called stromatolites, and they are a clue as to how the atmosphere filled with oxygen. Living stromatolites are incredibly rare. One of the few places on Earth where they can be found is in another part of the northern Mexican desert. This is the high valley of Cuatro Ciénegas.
You might think that this is just any old desert, but it's not. This is a very special place because of particular way the chemistry is in this valley. It's unlike any other place on the planet.
The pool is like a time capsule laboratory. By examining the modern stromatolites, scientists can work out how they were made more than 3 billion years ago.
What's interesting about Cuatro Ciénegas is that this is almost like a proxy to right before the world had a lot of oxygen in it. And the place was dominated, our Earth was dominated by microbial life.
Seifert has discovered that the stromatolites are made by billions of microbes called cyanobacteria. These bacteria were to change the course of Earth history because of one unique feature. They produce oxygen.
Here at this pond, we can actually see them doing their job. We can see them making that oxygen. So when I get in the water and I actually go up to one of these cyanobacterial mats, if I look very closely, all of the community is making oxygen. And as that oxygen collects in that mat, it produces a little air bubble. And you can watch that air bubble just transfer to the top, and that's actually when oxygen is being released to the atmosphere.
$3.5 billion years ago, oxygen was deadly poisonous to other early life forms, which used sulfur to obtain energy.
Cyanobacteria developed a little molecular machine that could actually take sunlight and take water, and they made a byproduct that was oxygen. Well, on this planet back then, none of the life was used to oxygen. And it's at that point in life's history when they began making excess oxygen that got into the atmosphere, our whole world changed in the way it worked.
Over geological time, there were enough cyanobacteria to produce trillions of tons of oxygen, creating the atmosphere we breathe today. And they were responsible for changing the way all life evolved.
From an evolutionary standpoint on planet Earth, we are where we are because of cyanobacteria and the fact that they managed to fill our atmosphere full of oxygen. Because unless we'd had that gas, we wouldn't have the complex organisms that we have on the planet. You and I wouldn't be here today.
Once the atmosphere began filling with oxygen, the stage was set for the evolution of all plant and animal life. The impact on Earth's geology was profound.